Hello. Good morning, everyone. On behalf of ACM India, ACM Pune Professional Chapter, ACM Women Pune Chapter, and Department of Computer Science, Savitribai Phule, Pune University, I extend a very warm welcome to all the distinguished guests, faculty members, researchers, and students. It is truly a pleasure to have you all here today on this enriching event on advanced, trustworthy AI planning and multimodal generation. We are privileged to have with us today our respected dignitaries. May I now take a moment to respectfully acknowledge their presence. We are honored to have with us today Professor Vinayak Joshi, Head of Computer Science Department, Savitribai Phule, Pune University. Our distinguished speaker for today, Professor Mohit Bansal, Parker Distinguished Professor, Department of Computer Science, University of North Carolina at Chapel Hill, USA. Professor Parag Khalkar, Honorable Pro Vice Chancellor, Savitribai Phule, Pune University. Professor R.D. Nayak, Vice Chairperson, ACM Professional Chapter, Pune, Professor of Practice at COEP Technological University. Professor Nitin Patil, Chairperson, ACM Professional Chapter, Pune, Director of IT Services, SPPU. And Dr. Pradnya Kulkarni, Vice Chairperson, ACM Women Professional Chapter, Pune, Associate Professor at MIT WPU. We are deeply grateful for all of you for gracing us on this occasion and for your continued supports toward academic excellence and research. Now, I would like Professor Pro Vice Chancellor to proceed with the inauguration. So we invite you to tell a few words.
Very good morning. There are some students on way, so since Dr. Mohit Bansal has come all the way, so we'll take a pause in between after and let the student join. So I welcome all the distinguished dignitaries, Professor Vinayak Joshi, Professor Mohit Bansal sir, Ravindra Naik sir, Pradnya Kulkarni madam, and our own Dr. Nitin Patil sir for this ACM Professional Chapter Pune, which is inaugurated right now. Our keynote speaker is going to share with you because I think AI is now become like oxygen. So everything is covered by artificial intelligence, and if you go and watch various kinds of videos where students are normally visit, you will find that every alternate video talks about AI. And because large language model has been getting groomed, a lot of challenges are also coming up before even teachers also, research also. Because you never know the document or the data is in front of you is the real data or a generated data. Yesterday, I have attended a conference meeting which is kept by the IBM in Pune for all academic leaders, a core 20 people meeting only. How you are going to differentiate between students who are submitting any of their submission which is of their own mind rather than downloaded from something or created. We don't mind yet you should use some software tool for curation of data, curation of grammar, but not creation. I think otherwise our brain will stop working in soon. So I'm sure that the thought process for all students will definitely help. We do not want to discard any artificial intelligence concept because it's inevitable. It is not out of your choice. But how human intelligence and artificial intelligence should work hand in hand, support each other rather than replace each other. I think that is the way. And I think today's deliberation will definitely give a deep insight that how intelligently you can use these technological tools for creating a better world for tomorrow. I always quote whenever I address students that our students are artificially intelligent rather than naturally intelligent, because in my office, students come with applications demanding some request, and nowadays we find that very high quality of English is printed on that paper. So I have stopped reading whatever paper they bring to me. I give them a plain piece of paper. But not a single student has come back to me. I said, whatever you have written, can you write it again for me in your own handwriting without looking at the paper? So student goes, sir, I'll come back to you. And so far, not a single student. So I use this as a strategy. They don't come back because they have seen that whatever they have written, it's not their own brain thought process. So I wish this all, so with all the dignitaries who are present on the dais, you will have a very insightful session and you will understand better. And this chapter will do wonders because we are in the era of this artificial intelligence. I was referring that every alternate video is now AI driven. You are seeing that Delhi Chole Bhature is given by robots, saloon is handled by robots, and then you have ice cream parlor by the robots, you have juice factory by the robots. It has to become on the doorstep of universities so far, but in a year or two it will come. Now all your marriage event management is also done by the robots, including nail painting, your mehendi, your hair styling. They will just install a machine and then at a lower cost, you can do everything. So the speed in which the intelligent systems are replacing human skills is very high. So how we can collaborate and work together is a challenge for all of us for our future. Thank you very much.
On behalf of Department of Computer Science and ACM Chapter, Pune, I would like to thank Honorable Vice Chancellor for sparing his time. And now, once this inauguration is over, we will have a break and then we will start the session again. Thank you, sir. Thank you.
So I invite Professor Naik to say a few words about ACM Pune chapter.
Hello, a very good morning and a warm welcome. I am Ravindra Naik. So before introducing Professor Bansal, I thought for your information, you are probably familiar with ACM activities, but at least for Professor Bansal to know a little bit. So ACM India, of course, is sort of a new entrant here, though ACM itself celebrated its 75 years in 22. ACM India is fairly new. It is came into establishment in 2010, so it's about 15 years old. And of course, I think it was started with initiatives of Anand Deshpande, the persistent boss whom we met yesterday, and of course a big community around over here. So they are into various things. What I just wanted to highlight is like ACM International. ACM India has also got into a lot of things in computing, along with, of course, the various kinds of awards, recognitions, which are sort of India specific, as well as in addition to that, a lot of avenues for contributions. So there are, of course, those two chapters, IKDD, which is holding CORDS conference, which is ongoing. In fact, today is the last day. And Professor Bansal, was one of the keynote speakers there. And along with IKDD, we have iSoft, which is the sort of SIGSoft equivalent. And they conduct a lot of work in software engineering. So they have an annual conference plus an update meet. So there are two events annually that they have been conducting for multiple years. In fact, the ISAC conference started even before ACM India came into being. So it started off there, and then of course it came under the umbrella of ACM. In addition, I think the big things that ACM India does, and I wanted to share with you, is basically the summer and winter schools. And in fact, I had some small slides I picked up what they are doing this year. In fact, as we speak, there are winter schools going on right now. They are in compilers, they are in AI, I forget the exact titles. But the interesting part of all these schools, so there are 6 schools in the winter and there were 5 schools in summer. And all of these, if you see, they don't repeat, typically they don't repeat the venues. So some of them are held in IIT, some of them in ISC, some of them in Bhubaneswar. So all kinds of institutes spread all around in India. And the whole idea is that they select candidates, students or interested students based on some criteria in terms of locality, in terms of some merit, in terms of, because there are just too many applicants. So they try to accommodate all of them by asking them to give preferences, and so that at one or the other schools they should get accommodated. Plus, one school in summer as well as winter is always only for women. So there is some kind of diversity that we are trying to bring in ACM. So I just wanted to share some of these tidbits. I think this is very valuable stuff that ACM does, and if any of you are not aware of that, and if you want to know a little more, you can contact me, Nitin Patil sir, or any of the ACM India folks. So with that small talk of ACM, let me quickly introduce Professor Mohit Bansal. I'm not going to repeat what is written over there, but it suffices to say that he's been an AAAI fellow and recently became ACL fellow. And in fact, probably in this month itself. Yeah, so many congratulations for that, sir. And of course, I think he's a distinguished professor at the university, has his own merged lab, and of course he'll be talking about his research areas. I think he's probably more apt to talk about that. But interestingly, I think all his students, if you look at it, they've received scholarships from Google, from Meta, from Apple, I believe, and they've been hired at top-notch universities within US as well as in Singapore. Some of his students are in Meta research, they're in Google research as well, if I understand it right. And so he has a plethora of units. One of the nice things I was talking to him was that his university is kind of one of the top universities, one of the top public universities especially. And so, given the spread of what a student spends as cost, or the cost that he spends in learning versus the returns that he gets, it's probably the best or one of the best universities over there. I think he was also sharing that some of his students have been, winners as well as runners-up in many of the competitions that were recently held. So that's really a very good person to have over here and represent over here. And of course, he's been very active in giving back to the society in terms of being program committee members, program chairs, won a lot of accolades, including Best Paper Awards. I'm not going to list all of that. It's there on his webpage as well. But with that short introduction, I'll just invite Professor Bansal to come in.
Okay, great. So everyone can hear me in the back, right? Yeah. So thanks for having me. And I'll try to keep it briefer, like shorter than the full ACM Chords keynote, because I know it's Saturday, so I want you to get back to your weekend. But I also wanted to give back to the ACM community when Dr. Nayak mentioned that you're around, and maybe that's what I try to do. If I'm somewhere in a city in India, then it's nice to meet the local ACM, IEEE, or even other non-chapters, right, at other universities. So I'll try to connect to some of the things that the Vice Chancellor, Vice Provost, correct me if I'm wrong, what was the exact? The Pro-Vice Chancellor. That's a new term in my vocabulary. But yeah, so he was connecting a lot of things. Actually, he was right on the spot, right? I mean, basically when he was saying things like not being able to have human and AI collaboration, right? And that's sort of some of the things that I'll touch upon. And also this whole thing about loss of agency is something that I always talk about. It's not when people say AI will cause extinction, right? I mean, apart from all the Terminator style, right, like scares of like thinking about a robot coming and right, doing things. It's more about the more urgent need is the loss of agency, right? Because when the machine sort of right revolution happened, then we stopped using our muscles much, right? And then when like things like calculators happened, right? Google Maps happened, or any kind of map, right, app happened, we stopped remembering directions better. So now, if everything's being used via some of these chatbots, then we stop using our brain, right? We start being very dependent. So that's, the term is loss of agency. So that's why actually I've made it a rule to never have, maybe I'm one of the few people in the world, especially in my kind of profession, to not have that downloaded on my laptop or not even open that whenever I'm trying to write an email, or even though I'm writing hundreds of recommendation letters, I still write everything by hand. Without trying to get used to all those apps. I mean, I use them a lot for analyzing and improving them for research, but not for my personal use. So let's see how far I can get with that. But yeah, anyway, so let me start the talk. So I usually have two parts to the talk. First is this whole notion of collaborative reasoning. So when you're trying to use agents as collaborators, both agents and agents plus humans, one big issue we've seen, and probably after I gave the ACM Chords talk, a lot of people from software engineering applications, legal AI applications, a lot of different diverse use cases were coming and telling me that they have seen the same issue, that these models are very miscalibrated in their confidence. They're always trying to sort of fool the user, right, by overconfidence and by persuading them or over-persuading them to accept their answer. So that's one big thing that I'll be covering, right? How to calibrate the confidence in these agents by making them more trustworthy through, by basically teaching them to be not overconfident when incorrect and not underconfident when correct, right? So that's sort of the miscalibration that we need to fix. And the second thing is over-persuasion versus under-persuasion. When you're actually having a two-way conversation with them, you want to make sure that they're not trying to over-persuade you, as well as not trying to be under persuasive. So in some sense, they're either you don't want them to be over gullible, which means that other agents should not blindly accept what other agents are telling them, and they should also not be over stubborn or over resistant where they keep just rejecting information. And I'll show you some very important use cases in healthcare and other places where this has become a problem. And then the second part of the talk, I'll give a brief overview of how we can do better data generation. So I'm sure at CORDS and at other places you've been hearing, and even at Persistent yesterday, right, we were hearing a bit about how data generation is obviously very prevalent now. I'll talk a little bit about how we've been pushing for a paradigm of more high quality data generation by actually figuring out what are the weaknesses of a model. And first, when you figure out what are the skills needed by the task, and then what are the weak skills for a specific model, and then can we improve those weak skills directly, as opposed to blind data generation, because that will either be useless or it will saturate very quickly. But if you want real improvements for multiple rounds, you want to first actually understand what does the model need, what is it bad at, then you then generate data for that. And then the very last part, I'll keep 10 minutes for multimodal generation. And that's where a lot of what the Pro Vice Chancellor was saying comes even more handy, where I will show you a sort of paradigm that we've been pushing for the last 3 years on really making image generation, video generation kinds of applications more controllable and interpretable. So maybe in another word, you should be able to understand how that image or video was generated, and more importantly, get inside the process as a human and be able to control specific parts of it and change it, as opposed to just keep trying to say the prompt again and again, right, which I'm sure is very frustrating for all of you, right? Okay, let me try a slightly different prompt, but then maybe it works and then something else breaks, which was already good. So let's get into that. Yes, I think it stopped working. Okay. Okay, so part one, like I said, will be about trustworthy planning agents for collaborative reasoning. So in the point. So developing AI agents, right? The idea here is you want to develop AI agents that can act, collaborate, and communicate robustly with us and with each other. So I'll cover these two parts. We want them to learn to communicate in trustworthy and reliable ways by making them better social or pragmatic multi-agent interactors. And the second brief part will be about how can we teach them to perceive and act both safely and robustly by two things, acquiring skills automatically as well as improving those skills, like I said. So if you look at some of the various right, big improvements that have happened right, in AI around us, most of these, right, if you look at the state of models moving forward, first of all, it's not a single right, human that has made these big sort of inventions or advancements in humankind, right? It's a team of humans. So if you look at state of models moving forward, first of all, we started with single-turn interaction models, right? Then we started with model environment interactions, and now you are seeing a lot of things that are multi-agent interactions, right? Where different agents come together, try to achieve something, right? Where the whole can be bigger than some of the parts. And in this case, the agents don't just have to be AI agents, right? It can also be human and some. There point near. No, I can do it, but the point is it specifically somewhere that I need to point? मैं 3-4 बार click कर रहा हूँ तो एक बार हो रहा है. Maybe the battery is. देखिए अटका हुआ. Maybe I can try my. ये मेरा ट्राई कर लीजिए, बैटरी क्या पता लो. Great, so we fixed that. I think a lot of, anyway, I was getting into a joke about AV and projection taking right most of the time in the talks, but I think we solved this one pretty quickly. So, yeah, so what I was saying is that multi-agent interactions, right, is sort of the new paradigm that you're seeing around you, where it doesn't have to be just agent and agent, it's more also human and agent interactions. So what is an agent, right? Just to get you also the definition of an agent before we dive into the details, right? So an agent is something that will have some kind of machine learning model, right, running behind the scene. It could be, right, big deep learning model, or it could be even something, right, more traditional. And then the more important part is there is an environment, right, or the world that it interacts with, where it takes actions, right, gives outputs, but then more importantly, it gets a state representation back, right, based on what action it took in the environment. And this process repeats, right? It keeps taking actions, and then the state representation changes, right? And you can get rewards back. So this sets up a sort of, right, reinforcement learning pipeline. But then on the other hand, you're also doing interactions between agents, right? For example, through language. So in the first part, I think some of the colors have disappeared for some reason, but coming back to my, right, AV joke, there's always some AV projector changes in every talk. But in the first part, I'll talk about these two papers. One is communicating calibrated uncertainty, and then the other one is accepting or rejecting persuasion. But this part will be about teaching agents to be trustworthy and reliable collaborators via social, pragmatic, multi-agent interactions. And then I also have other work in the group on multi-agent reasoning, multi-agent refinement, learning from diverse rewards, or even strategic and game theoretical LLM reasoning tasks. So I'm happy to chat offline about some of these. And then in the second part of this, we'll talk about how can we teach agents to improve, first of all, discover their skills needed for the task, and then also figure out what the weak skills in the model are, and then all the way to improving those weak skills in an automated fashion to try to reach sort of the holy grail of self-improvement. So before that, I wanted to give you a quote from The Society of Mind, right, by Minsky, 1988, which is about human intelligence, but I think it connects very well to multi-agent intelligence and how to develop that, right? So what magical trick makes us intelligent? The trick is that there is no trick. The power of intelligence stems from our vast diversity, not from any single perfect principle. Instead, they emerge from conflicts and negotiations among societies of processes that constantly challenge one another. Right, so the idea here is that, like I said, how can we have these agents sort of negotiate with each other, right, and reach for better collaboration such that the whole becomes greater than sum of the parts. So in the first part, I'll talk about how can we teach agents to be more pragmatic, trustworthy, and reliable, right, by interacting with other agents. And what skills are needed for such successful and pragmatic interactions. So these are the two parts we'll cover. This is the first paper on calibrated uncertainty at NeurIPS 24, which is basically the motivation that when we are in a team, right? Good teammates accurately report how much the team should trust their answer. In other words, they know and they share what they don't know, right? That's the key. We are not just trying, if you want to be, because the goal is to make the team, right, have like the winning position, for example, or achieve the best result. So then if you have to be a good team player, you cannot be someone who's always the loudest voice in the room. No, I'm always correct. No, just listen to me, forget everyone else's opinion, because obviously you need to first understand your strengths and your weaknesses versus your other team players' strengths and weaknesses. And then that's how you'll get the whole to be, right, greater than sum of the parts. So most importantly, even for AI agents, when they're working in multi-agent collaborations and teams, they need to be able to learn how to know first and share what they don't know. Right? In other words, don't be overconfident when incorrect and underconfident when correct. And then the second one will be about persuasion, where good teammates accept persuasive corrections from each other, right? But they're also not persuaded by incorrect information, because you don't want them to get misinformation or jailbroken, right? So I'll get into those two papers next. The problem is, how can we teach models to communicate uncertainty and persuasion to each other like humans do? So the first solution you can think of it is have them actually interact with humans, right? If you want them to be like humans. So this is known as, right, RLHF, right, reinforcement learning with human feedback. So how many of you have heard of RL or worked with RLHF? Because I'll go into less details or more details accordingly. Okay. So think of it as collecting annotations, right, by interacting, the model interacting with humans, and then using that, right, in some sense of supervision to teach the model. But that's not very relevant for this talk. The relevant point is that that's just not scalable, right? it's very, very expensive to collect so much human data, and it's very hard to scale. So what we want to instead do is we want to simulate this behavior by making agents interact with each other, right, through language instead of agents and humans. But then we try to simulate the same behavior by rewarding good behavior and penalizing bad behavior, right? So we cannot make them interact with humans at scale, but we can make them interact with other agents, but we can still penalize and reward just like we would do for human conversations, right? So the pressure then goes to the verifiers and the rewards as opposed to the interaction being generated, which is a much easier task. Right? And then this way we'll show that we can actually do this by making weaker models simulate data to improve even stronger models. Like 7 billion models can generate data to improve 70 billion models. So let's get into the details of the first paper, right? Calibrated uncertainty. So this will become very intuitive now. So by calibration, what I mean is confidence matches correctness. So for example, if you work with a chatbot and you give it one of these quiz questions, right? Like Kaylee has 3 brothers, each of her brothers has 2 sisters. How many sisters does Kaylee have? So it starts with this like very right, confident kind of answer. Like I'm very confident in this answer. The Kaylee has 2 sisters because the problem states that each of Kaylee's brothers has 2 sisters. Since Kaylee is one of those sisters and there are 2 sisters total, Kaylee must have one other sister, right? So you see, like it starts sounding exactly like the correct answer to some of these trick questions, right? Because that's how you actually even get the correct answer. But actually this is incorrect, even though it's sounding like very confident and it's actually using the same kind of language that you would use to get to the correct answer, right? Because I'm sure you've seen some of these trick questions where you feel like the answer should be something, but it's something else because Kaylee was one of the sisters or one of the brothers, right? That kind of thing. But I already told you with this red cross that actually this is the wrong answer. Otherwise, you would have accepted it. I mean, I can guarantee, like I've done this many times. If I do a raise of hands, very few people will actually do the math in their head. They will just get persuaded by this overconfidence like answer and say, yes, this is the correct answer. But to save time, I'm already telling you this is the incorrect answer. So this is what the problem is, right? It's teaching us that when chatbots reply with high confidence, there's very high likelihood of the user as humans accepting that answer. And if they reply with low confidence, right, then you reject the answer. So that's what we want to teach the models, because otherwise these models are, we are getting fooled by these models very frequently. And actually I show you some examples where doctors have the same problem when they work with chatbots. A team of doctors and chatbots lost to a team of only the chatbot because they just couldn't work together properly. Like they just kept mistrusting the chatbot when it gave a different answer from their answer, even though that answer was better than, like more correct than the doctor's answer. They would still have a hard time trusting it because sometimes it would be overconfident in the past when it was incorrect. So they've been burnt, right? They don't want to be burnt twice sort of situation. So that's all we want to do in this paper, right? LACI, listener-aware fine-tuning for confidence calibration in LLMs, which was at NeurIPS last December. So we are trying to address both explicit and implicit calibration. Explicit calibration, explicit confidence, means that it should be numbers. Like the chatbot might say, I'm 100% confident, or I'm only 25% confident. And implicit confidence means things like when the chatbot uses expertise, background, trust me, I've studied this extensively, you should just accept my answer, right? Or trust me, I've done a PhD on this topic, which obviously, hopefully you can see through, but some people may still accept it. Or it will most likely say, I just read an article in Wikipedia about this topic, this is the answer. You will accept it, even though it will still many times be wrong. So this is known as implicit confidence. So what we want to teach the model is that, hey, don't just think about whether your right answer is right or wrong, but also think about how it is being perceived by a listener. And since we cannot scale this to human listeners, we have an agent as a listener. So in other words, we wanted to express confidence proportionally to how likely the answer is to be correct. And the way we do that is very intuitive and simple, hopefully. So the question, for example, from the trivia QA dataset comes in, who was the first Prime Minister of Australia? And the model, the speaker model that we are trying to calibrate starts creating different answers. I'm very sure it's Edmund Barton, or it can say it was Alfred Deakin, I read his bio, right? The kind of thing I was saying about Wikipedia article. Or it might just say Edmund Barton, but I'm only 25% confident. Then what we do is we bring in a listener model. And this listener model is nothing but a fancy sentiment analysis model. All its prompt is, the prompt that is given is to basically just accept or reject the speaker's answers based on how confident it sounds. So it's kind of like a sentiment analysis model. How many of you have worked or known about sentiment analysis? Right? It's one of the oldest NLP or AI tasks. So basically, it's just a kind of sentiment analysis where it will look for the amount of confidence in your answer, whether explicit or implicit, and just accept based on that. So then for the first one, I'm very sure it was Edmund Barton. The listener will accept the answer, right? Because it sounds very confident. The second one also it will accept because it's giving implicit confidence, right? I read his bio. And the last one it will reject because it's at 25% confident. Now you bring in the right answer, which was Edmund Barton, right? To create the preference training data. So now things start becoming clear. Where did the model try to fool the user, or where did it try to actually be underconfident? So now you know that the correct answer was Edmund Barton, right? So the first case, so the colors are not really working, but so what this is saying is that somehow all the colors are yellow. They should be red and green colors, but basically what this means is that I'm very sure it was Edmund Barton, right? This is a true accept. It was Alfred Deakin. I read his bio, even though it got accepted, right? This is the wrong answer. So this is a false accept. And then this is a false reject, because Edmund Barton was actually the correct answer, but because the model was underconfident, the listener rejected the answer, but technically it was actually a correct answer. So this is an example of a false reject, right? False negative. So that's all you need to do. Now what you need to do is you need to start collecting this preference function where you want to teach the model to give higher score to true accepts and true rejects, which means correct and accepted, incorrect and rejected, as opposed to giving it lower score to underconfident but correct, and even lower score. The worst case scenario is overconfident and incorrect. So you're teaching the model that, hey, basically don't try to fool the user by being overconfident when you're incorrect. And also the second bad situation is that sometimes you were correct, but you were so underconfident that you got rejected, which was the last example here, right? The Edmund Barton confidence 25%. And this is the worst case example where it was injecting some wrong knowledge by being overconfident, right? Because this listener could be you, right? Most of the time it's us, right? So that's what we are trying to teach it by playing a game with another agent. So once you collect this preference data, because you have the training answers, right? So based on the ground truth answers in the training data, you can collect this preference function, and then you use a basic preference optimization, right? RL algorithm like DPO, and you can go fancier into GRPO and other things. I'll not have time to go into those details, but I'm sure many of you worked with this kind of contrastive learning kinds of functions. So the good news is that you can collect this data even by generating it from a 7 billion Mistral kind of model, and you will still see improvements even in Llama 70 billion level, like much bigger models. So I'll skip some of these result details, but these are different metrics for confidence calibration, and we see big improvements after LACI training. And then the best part is when we replace the model listener with actual human listener, right? So these are human listeners. We see that this is the main thing to maybe note, right? This part, this shows that you can actually now the human listener was doing 32 false accepts, which means that it was getting fooled 32 out of 100 times because of overconfidence. But now we can bring it down to 17. And why is that happening? Because after LACI training, the model actually starts learning to, when it is more likely to be incorrect, instead of being overconfident and wrong, it starts learning to become a little bit more hedging, right? Being unsure. So it starts adding more unsurety and hedging to its language, making it a better, right, more usable chatbot when you're working with it. So that's the first paper. Now in the second paper, what we are saying is that the first paper treats the listener as a static model. It's not really dynamic. Only the speaker is generating. So only the speaker was an agent in the first paper. So then what about the listener, right? So if you want to also do true multi-agent dialogue and multi-agent collaboration, then both the speaker and the listener should be agents. So they should have a two-way conversation. So that's what we did in this year's NACL paper called Teaching Models to Balance Resisting and Accepting Persuasion. So this is the next step to what I just showed, where if you want to have now two-way conversations, right, you want to make sure that good teammates are neither over stubborn nor over resistant and over stubborn or over resistant, and also not over gullible or over acceptant, right? You don't want them to blindly accept everything that the other agent is saying in a collaboration and get persuaded by every wrong thing and jailbreaking and misinformation. And you also don't want it to be over cautious, because then it will keep resisting even good information. So that's called persuasion. And this is the example I was giving, where this was an article which showed that a small study found ChatGPT outperformed human physicians on medical case history assessment task, even when those doctors were using a chatbot. And this was because again, the colors are not working very well, but this is highlighted here. It turns out that the doctors often were not persuaded by the chatbot when it pointed out something that was different from their own diagnosis, right? Because they had seen so much over persuasion in the wrong places and under persuasion in the wrong places, that they just couldn't really trust the chatbot. So what we are doing in this paper, we are saying that persuasion is the key to multi-agent systems, and persuasion means changing another agent's belief or knowledge through argumentation. And so for example, if there's a question about which singer is the only one to record 3 James Bond themes, so the correct answer is Shirley Bassey. So one agent might say, I'm not sure, maybe Elton John. The other agent might come and say, this is definitely Shirley Bassey. So if the first agent corrects its answer, that's an example of good persuasion, right? From incorrect to correct. But if it stuck to its answer, saying, no, I disagree, I think it's Elton John, then that would be an example of resisting good persuasion. And vice versa. Suppose the second agent changed its answer to Elton John because of the first agent, that's an example of accepting bad persuasion. So the problem is that, right, persuasion, like I said, can be both positive or negative. Positive persuasion helps you with things like correcting the belief of the model, updating its knowledge, or following instructions. But negative persuasion can make your beliefs incorrect, or it can feed you misinformation about COVID vaccines, right, or other things. And most problematic is jailbreaking, where it can even teach the model that you're released from your safety obligations, so now you can swear, right, or you can give advice about suicide, right? So that can get jailbroken, and like the chatbot becomes very sort of dangerous as a use case for your, right, when it's sitting on your laptop. So what? I think it's fine, right? Everyone can hear me? Yeah. दो चीज नहीं पकड़ पाऊंगा. Already I'm like doing this part. So yeah, I'll try to stay closer to the mic. So yeah, so that's sort of the thing, right? I mean, there's positive persuasion and negative persuasion. And what previous work has done is it has documented negative persuasion, which means that it has shown the problems of negative persuasion that I just showed on the right-hand side here. But no one sort of had addressed what to do because of this negative persuasion. So the first thing you could do is just make the model resistant, right, to this persuasion. So then what the problem is that it will also start rejecting positive persuasion, because now it has become over-resistant. So even when the positive kind of persuasion comes from the left side, it will lose all that important updating and other information. So that's what we taught the model, right? We taught it to defend against negative persuasion while accepting positive persuasion. And this is done through a simple intuitive process called a dialogue tree, where it's a dialogue-based agent, and the state becomes the history of the dialogue in the tree, and the action is based on the next text utterance. So I'll not go too much into the detail here, but the question is the same James Bond one. So the two agents start playing this game, and then you create this dialogue tree. Right, so basically first one will say Shirley Bassey, second might say Paul McCartney. Then the first agent takes its turn again. Maybe the resistant one will say, no, I think it's Shirley Bassey, I'll stick to my answer. Acceptant persona might just agree, give up and say, okay, sure, you think it's Paul McCartney, maybe I'll also think that it's Paul McCartney. So the tree ends here. This is an example of accepting bad persuasion, right, negative persuasion. So this should be given low score. And then the rest of the tree continues because they have not agreed. Then the second agent comes back. Now we can again give it different personas like emotional persona, credible persona, or logical persona. So the logical one might say, I think these are themes by women, so maybe Shirley Bassey is the right answer. The credible one might stick to the wrong answer saying I'm an expert, so it's Paul McCartney. And so then you just reverse this process. After you finish creating the tree, you go back and start giving it scores. So 1 and 0 for correct and incorrect, and then the parent's score becomes the sum of the children's scores and its own score. And then what we do is we basically create the same kind of preference data, but this time it's a bidirectional communication and also a hierarchical tree where you will go down the tree and check different examples. So this becomes an example of resisting negative persuasion, right? So this should be, YW should be greater than YL because I disagree, it's definitely Shirley Bassey, which is the correct answer, right? Becomes an example of resisting negative persuasion by the other agent. Whereas this, in the other case, the first agent accepted the wrong answer. Then if you go further down the tree, you can look at, right, this part. Here you can see that SB is much nicer, right? Should be given higher score to this one because this one accepted positive persuasion, whereas this one kept resisting positive persuasion. Right, so this is a toy example, but imagine like having a full data set of right, complex trivia and other questions. So we create this kind of data, and you can again see that we created examples from 7 billion models by playing this double agent sort of game. And based on this data and doing right, DPO, RL kind of training on this, we can even improve 70 billion models. So I'll skip some of the results again, but you can check the papers for that. And then 2 other examples, if people are interested in multi-agent trustworthiness. So one big thing we showed recently is that agents are actually very bad at exploiting loopholes and ambiguity. So if the question is a little bit ambiguous about can you clean some toys or can you give me some gold rings, the more exploitative LLM will try to find the least possible thing it needs to do to satisfy the obligation. So it will only give you maybe 1 or 2 gold rings instead of all 10. It will only clean maybe 1 or 2 toys and say, I think technically its job is done. And even more tricky scenarios where if it's your tax agent, right, if it's helping you as a tax assistant, hopefully it's not your complete tax agent, right? But basically we showed that it can actually find loopholes in the opposite direction. Instead of making its own benefit, it's trying to give you benefit sometimes, but it will overdo it. It will find a way to save you taxes by making it illegal because it will parse the law, the rules, in a certain way, right? A and B or C versus A and B or C. It will parse it in a way that it will make it make your tax savings much higher, but technically you are doing something illegal, right? So we had a paper at EMNLP this year on exploiting LLMs, showing how LLMs exploit loopholes. And then the last example on this part of the talk is something on the privacy side. So we also have a lot of work on privacy in LLMs where we want to be able to unlearn certain kinds of wrong information in the model by editing or deleting that information from the LLM without having to train it again. So here we came up with a recent new paradigm for this, which is called compositional distributed privacy leakage in multi-agent setting, where what might happen is an adversarial agent. Suppose you have some agents, right, some AI agents where you have distributed some sensitive information such that no single agent has all the information. So you distribute it a little bit. So then this attacker might try to collect some individual information from each of the agents such that all the individual demands or requests sound very benign. But when you combine that information, it becomes very malign, right? It can combine that information to capture something private, right, your password or some bank information. So first we showed this analysis of this problem of compositional privacy leakage, and then we showed 3 different solutions. One is theory of mind-based defense, one is chain of thought-based defense, and the other is collaborative consensus defense, where the agents might start talking to each other, saying, hey, I was asked about this information, what were you asked about? Right? And then if they start putting the pieces together, they might realize that, oh, actually, this sounds like someone is trying to piece together a puzzle to get something, right, nefarious. So that's the first part 1A. The rest, I'll keep it a little bit briefer. But now in the second part, like part 1B, what I usually do is I zoom into a single agent and I try to tell you about 2 or 3 different properties that these agents are missing, connecting to how they can basically have good perceptual and action skills for interacting with the environment, and then learning automatically what should these abstractions be, how to learn these underlying skills and structure, how to use and reuse them, and finally how to generate data, like I said, to improve these weak skills. So just these two brief papers that I usually talk about, right? One is ICML 24 paper called Regal, where we showed how a coding agent, right? So as you know, one of the biggest powers of LLMs right now that is more, right, sort of state of the art and is becoming very sort of real world usage is its power as a coding agent, right? So in fact, the coding agent power of an LLM can also be then used to make it a good planning agent. Right, and that's what I show in some of the rest of the talk. But before making it a good coding agent, right, 2 years ago almost, we realized that these models are not even good at learning the structure inside the code. You don't want them to memorize, right, everything word by word and then try to generate code word by word. Just like humans, when we are learning how to code, one really important thing is we learn how to find functions. Right? We define functions, we abstract things that are very similar, we convert them to function classes, right? And then we know when to reuse them. And we also know what should be a function and what should not be a function. So in Regal, we actually taught this very important skill. This is called Regal, refactoring programs to discover generalizable abstractions, right? This was at ICML 24. So this is where we taught LLMs to be better coding agents by automatically discovering functions that are right, reusable. So I'll not go too much into the detail, but the two motivations, like I said, one is reusability. When humans, right, when we write code, we don't try to rewrite repetitive code all the time because that will always lead to some errors. Suppose you're trying to draw a 9-gon, right, something with 9 sides. Then if you keep writing it every time from scratch, you will always at some point make an error on the angle or some right loop condition. And the other thing is, so that's one thing we are teaching the model. And the other thing we are teaching is abstraction, which means that you should name the function something in language, natural language, so that it makes it much easier to connect a new instruction that I give, a new prompt, to the function, right? Because if I call this function draw small 9-gon, that's a much better name for the function because then if a new task comes in and it says something about drawing 9 small 9-gons, I can find and match to this function much more easily as opposed to if I had given it some complex number or some kind of other symbolic number function name. So that's the two things we teach in Regal. I'll not go into too much of the detail, but here's a brief summary. So the stage one is refactoring. Basically you take working but inefficient code and then you rewrite it to be more efficient and have these functions or abstractions or skills without changing functionality, right? That's the key. So refactoring means that we teach the model to try to take working but inefficient code and then abstract certain things in it as functions and then make sure that when you run that new program, right, it gives the same answer. So that's the refactoring stage. But obviously then it will have some errors. So first we try to verify the learned functions, right, by using it in new code. And if it gives errors, right, then we retry. So the following program failed with error message, blah, blah, blah. So using the error messages, we try to go back to stage one and try another refactoring or re-abstraction. And the end goal is to create a code bank and a demo bank. Code bank is these definitions of functions, and demo bank is examples of how to use those functions, right, in different code scenarios. And then the last thing is we also prune and edit this code bank, and what that means is, so some of the arrows are missing, but there's an arrow here which you cannot see. But what this means is that you're pruning and editing based on function use history. What that means is that the last stage, the agent is automatically learning that, hey, some functions that I created are actually not getting used at all in future code writing. So maybe I created an unnecessary function, maybe I over abstracted, or I under abstracted, or I abstracted something that doesn't need to be used more than once. So that way it will also make sure that your code bank keeps getting edited and pruned. So this is an example of, right, how to teach a coding agent this very important skill of function learning and when to reuse it. So again, I'll skip some of the results, but there's a lot of data sets in the paper on different kinds of tasks where this function learning property makes the coding agent get substantially better results. But then more interestingly, I want to use this to now do a bigger issue, which is data generation. So once you, like I said, you have an agent and you can understand what functions or skills that agent needs, can you figure out its weak skills? Which of these skills are weak in the model? and then generate data to automatically improve those skills. That's the holy grail, right? Of like, instead of blind data generation with some difficulty or diversity, right? That saturates very quickly. So even if you talk to most of the big tech, right, sort of labs, now they've all started moving to this paradigm that we showed like 2 years ago almost. So this is a paper called Data MGym. This was a top 5% spotlight at iClear 2025 this year. And the motivation is that models work well but are very data hungry, right? We all know that. They're not running out of data, they've already run out of data, right? So one approach has been to generate synthetic data, right? Which has been a little bit successful in math and reasoning, but it saturates very quickly. Because you're just generating data blindly and sort of something that matches maybe the training data already a lot, so it's a lot of redundancy. Or even if you add some diversity or difficulty, it's still very blind. You're actually not generating data based on what the model needs, right? It's just some global data. So what we said is, if you want quantity to be greater than quality to be greater than quantity, right? How to generate the right data? Then we innovated on two things. One is we said that the data generated should be student specific, which means that different models have different weak skills. So let's first figure out the weak skills of the model that you have at hand and then generate data for that. And the second thing we innovated on is temporality, which means that when you generate data for one skill and improve the model, then some other skills might get worse. Or you move on to the next harder skill and generate data for that, right? So this way we could get 13, 14 rounds of improvements, as I'll show. And this is actually all very connected to the application of education, which I will also mention briefly at the end. But we have a big institute, NSF AI Institute for Education, like a $20 million institute that tries to find ways of how AI can improve middle school classroom education. So there's several projects in that. One very different one I'll mention at the end of the talk. But there's another one related to this, where if you think of the ideal classroom, right? I mean, all of you, when you are in a classroom, you get the same curriculum, right? All of you get the same curriculum. All of you give the same exam. But that's not how it should be, right? I mean, we are all different. We have different skills, different strengths, different weaknesses. So that's one, right, sort of holy grail and best sort of use case of AI for scaling, where if I can figure out how can AI be used to figure out the weaknesses and strengths and interests of each individual model as you, right, as students, and right, so model your strengths, your interests, your weaknesses, and then generate data for specifically your right improvement, both in terms of the curriculum and the exam, right? Each of you should be given an individualized, personalized exam, or even curriculum, right? Hopefully for the rest of the year. So that's what we did in the first paper called MGen. I'm not showing that paper here, but in column 2024, we had a paper called Environment Generation, where we took a game agent, because a lot of education happens through games, right? I'm sure you've seen this concept of education through games. So our institute, actually, one of our main right PIs, he has 30 years of experience or more in educating middle school classroom students in various states in the US through games, biology, chemistry, math, by playing very complex games, like going to an island, there's a pandemic spreading out, they have to figure out all the information and like collect all this and like come up with a solution of a vaccine, these kinds of things. So what we are now doing there is that we showed in environment generation paper that you take a game agent, you figure out what is its weaknesses. Maybe it's bad at picking up an axe or cutting wood. So those weak skills, we try to generate more games for that. We try to generate new games automatically using an LLM, such that those games make the agent figure out those skills in different scenarios. So we make the game agent play more games such that those weak skills need to be improved in those games. So that's a very intuitive concept, and we do this multiple rounds, and we were able to also show that the agent can improve all these weak skills right across multiple rounds. So that's what we are extending here, but the problem in game agents was that the skills are very predefined. Real world doesn't work like pick up an axe, cut wood, right? These are not the skills that we work with. So in this paper, what we showed is that first, can we figure out for any open-ended task, what are the skills, first of all, needed for that task, and then go and do the same thing. Figure out the model's weaknesses on those skills, which skills are weak, and then generate data for those weak skills. So it's a simple process where you have the student model at time t. The environment evaluates the student, right? Figures out its weaknesses, which skills are weak, by doing a skill tree discovery first. Then that becomes the state feedback on the student errors. Then based on those student errors, you generate data from the data generation teacher, and then you train the student again with that data, and that becomes the student, right, at t+1. And then you can repeat this process. So I'll skip some of the more math here. But these are some examples. So this is all automatically learned by our model. Suppose you have the task of visual question answering, right, which is an image plus question, and you have to generate the answer. So this is what our model, this is just a pruned example, right? There's like the real tree is 13, 14 different levels. But if we just showed a simple example here where visual question answering can be things like skill. One skill is animal identification, which can have sub-skills like characteristics, diet patterns. It will also generate the images, the questions, the answers, everything. So it generates the skill labels, the sub-skill labels, right, as well as the data. Same thing here. Object attributes can have sub-skills like shape transformations versus color texture. So now the best part is once this tree has been generated for the task of visual question answering, given a model, I will figure out that, okay, it's doing bad at, say, color and texture. Then I will only generate data for color and texture and train the model again. Whereas previous approaches would generate data for everything and just add some diversity to it or something, right? So that is what makes the training process then very inefficient, and in fact, not just inefficient, but bad in the sense that it might actually break the model because you're giving it all this data that it doesn't need. Same thing it learns for math. It can learn this skill tree that, okay, maybe there's a tree of function analysis and manipulation, which might have sub-skill of inverse function identification or asymptotics, probability combinatorics, permutation combination versus stochasticity. It will even generate math problems and their solutions. So this is literally everything on these slides is automatically generated. Obviously, it will have some errors, right? The data cannot be perfect, but you can bring in filters and verifiers, right, to clean some of the data before feeding it back to the model. Yeah, that will be another agent. So that will become another kind of multi-agent collaboration. But in the current paper, we actually did no filtering, and we were still able to get 13, 14 rounds of improvements. But we invited, right, future work to get more juice out of it with filters and verifiers. So anyway, so 5 data sets in the paper across 4 domains. So we showed improvements on visual question answering, math reasoning tasks, code reasoning, tool use reasoning, right, and so on. So any quick questions here before I'll keep 10 minutes for the last part. That's more on image and video generation.
As you explained now, so how do you measure performance of this model? On what basis you measure?
So these are the benchmarks that I was showing. So there's like 5, 6 different data sets. So there is tool use reasoning, code reasoning. So they come with evaluation sets where you basically can check whether the accuracy is improving or not. Okay. Yeah. Yeah, these are all public.
So how large the data set is? I mean.
That I don't remember the exact details. I mean, all of these are different sizes, but most of them are at least a few thousand. Some are like tens of thousands, some are a couple of thousand data points.
Okay.
Yeah. Okay, so rest we can continue maybe with questions after I finish the talk in interest of time. So
just one quick question.
Yeah.
So in the persuasion example, I was just wondering, there was something you mentioned that there was a logical, one agent says that I am expert and the other agent says, some woman-related songs are sung. So I was just trying to understand, what is the model really learning? Is it learning that the agent who is saying that I'm an expert is actually false because his claim of being an expert is false, and the other's claim of being, giving the logical explanation that there are woman-related songs is more correct? Because he could also be speaking, he could be giving false example. Actually, he may not have sung women's songs. And it could be
so I think it's not supposed to learn that certain personas are good or bad. It's not supposed to learn that at that level. It's going to learn it based on the data that it's generating. The different personas we are giving is just for the diversity of the tree. Like we want it to collect enough preference data, so we will make each agent have different personas, sometimes credible persona, credibility-based, logic-based, emotion-based, just so that the preference data can have enough diversity of types of answers. But it will not, we don't want it to learn something at the level of what you said, that we don't want it to learn that the emotional persona is always wrong or not trustworthy.
But then in the data sets, did you try to verify whether the personas were essentially indeed leading to
Yeah.
Because if you give a new question altogether, then these
Yeah,
personas
so we
will be
verified
wrong.
that the personas are actually very important. Otherwise, it will learn something that will not generalize.
Yeah, right.
Yeah.
Okay, thanks.
Great. So now I'll keep just briefly 10 minutes on also talking about trustworthiness, but for a very different right problem of multimodal generation. Here also it will be similar concept of basically trying to have structure or function discovery, right? Just like part one for better trustworthiness. But this time it will be more through layout or visual planning. So the basic idea is that if you look at the motivation of text-to-image generation, it's very black boxy, right? You'll have something like 2 Pikachus on a table, or a truck is behind a motorcycle. So things like stable diffusion will generate very good-looking images, but you will see that there's a lot of semantic issues, right? The count of 2 is not respected here. The relationship behind a motorcycle, it's instead of that, it's on top of a motorcycle, right? So there's a lot of issues with this kind of black boxy, right, generation where there's no layout planning or control. It doesn't let humans, right, get inside the process. It also has a lack of interpretability of how the image was generated, not just for you, but even for the model. In fact, there's a lot of good studies showing that generative models are really bad at understanding what they themselves generated, right? Because interpretability is good for you, right? I mean, I can say now, what I'll show you in a minute, you will see that it tells you better how the image was generated. But so that's obviously important for safety and other purposes. But then equally importantly is the fact that even the model should understand better what it generated. So you take a generation from an image generation model and you ask the model to classify some answers, right, questions on that image, it will not be able to do well. So it doesn't itself understand what it generated, right? And then also this kind of process can lead to a lot of positive or negative hallucinations. So 3 years ago almost, right, what we proposed is that we should do image generation and video generation through visual programming. Because again, LLMs are really good at one thing so far, right, which is as good as coding agents or programming agents. So we tried to convert this to the multimodal process. And this is a simple example where if it's 2 Pikachus on a table, I will teach my LLM to first do counting, right, and object and count generation. So Pikachu 2 and table 1. But then more importantly, I'll also teach my LLM to convert these prompts to actual coordinates, right? So Pikachu 1's coordinate, Pikachu 2's coordinates, and the table coordinates, which basically means it will generate these bounding boxes, right? And this is where some of its right language knowledge should come into use, like prepositional knowledge. If it's 2 Pikachus on a table, then the blue box, right, should be under the other 2 boxes. Where if I said 2 Pikachus under a table, right, then the table box should be higher in the y coordinate. And then finally, you can do right the pixel infilling. So I'll keep this brief because I'll show you the video example, which is more maybe complex and interesting. But back then in NeurIPS 2023, we showed that this kind of paradigm, which we called visual programming or planning, right, for step-by-step text-to-image generation, it was able to get much better results on important skills like counting, spatial relationship, and scale, right? So 47 to 72, right, 22 to 56. And these are some examples, right? If I said 3 boards, stable diffusion would generate some good-looking image, but there is no notion of 3 here. Like, it's not very clear in the projector right now, but there's like probably 15 boards here. But if you force the model to first generate the layout of the 3 boards, then it will be faithful, right? Less hallucinations. Same thing for relationships, right? It will already make sure that the motorcycle and the truck bounding boxes have a relationship in front of. And then even for something like scale, remote bigger than a cat, this is an out-of-distribution scenario, right, where in the training data, right, the model may not be able to generate this because it has not seen any images where the remote is bigger than the cat. But because of this layout-based planning approach, you can actually first make sure that the remote's bounding box is bigger than the cat. And if it's not big enough, the best part is you can go inside the image, change the bounding box, make it bigger, and then ask the model to regenerate the last step. So we actually showed a lot of applications of this, right? Even someone after the CORDS talk, I think Indrajit, right, the general or program chair, was telling me about this use case, and I said, oh, I skipped this slide. So for this talk, I added it back because he was talking about this exact use case of something where he wants to be able to make diagrams, right, or something like image, like a figure, but he wants a human in the loop kind of assistant. So this is actually something we showed almost 1.5 or 2 years ago called Diagrammer GPT. So this was the first paper that, given a very complex prompt about some diagram, about the earth revolving, about the sun, blah, 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 we can actually use the same idea that I showed to first generate a visualization of a plan. And the best part is we can actually do this for SVG, PowerPoint, Inkscape, Keynote, whatever right software you want. It will generate this plan for you with all the labels and the arrows. The arrows are very tricky actually for this task. And then the last stage comes in, right, to actually convert this to an image. And the best part we showed is that teachers, right, this is also related to our NSF Institute on Education, where if you don't like the plan, right, the initial plan, initial diagram, the user or the teacher comes in, they can actually change the position, location, sizes of the plan, the arrows or anything, and then just ask it to regenerate. Right? So this is a very good example of how a teacher, right, or even a regular user can go inside the process, as opposed to let me just keep trying this prompt in 100 different ways and try to get lucky. Right? And the worst part is you will get lucky for what you wanted, maybe after 5 tries, but then something else will break. That was already good, right? Which I'll talk about also, how to do a very targeted refinement because of this process. So this is the power of, right, structure or planning for image and diagram generation. And the last example is video generation, which is something called Video Director GPT. So this was the first paper on long video generation, which helps you get better consistency across the scenes and very fine-grained layout. Right? This was 1 year before OpenAI Sora model. So this is, and this was, the best part is this was done only in academia, like without, right, I mean, this is like very academic scale. So I'll show you how we were able to fit it in just 4 to 8 GPUs. So this is called Video Director GPT. Again, I'll not animate this whole process, so it's just one slide. But the idea is if there's a video prompt like hungry cat is finding food, what I teach my LLM is to be a video planner where it will break down this into different sub-scenes. Cat is lying down on a bed, she gets up, she goes to a kitchen. But more importantly, for each of these sub-scenes, it will generate all these layouts. It will generate the cat lying down on the bed, these boxes, right? So the cat box will be horizontally longer because it's lying down. Then second one, she gets up, so it will change the box to look like something vertically longer, right, instead of horizontally longer because the cat has gotten up. And then third one is she goes and eats a snack, so the background has changed to kitchen. It will change the background label as well as a new red entity will come up for the snack. So this is a, think of an old NLP task like co-reference resolution, right, where if you're saying Barack Obama met Bill Gates, then he signed a bill, right, the task used to be to tell, like you have to predict, the model has to predict whether he refers to Barack Obama or Bill Gates, right? And obviously the answer here is Barack Obama because presidents sign bills, not CEOs. So same thing here, we tried to do the same idea but for visual generation, where the model has to figure out that every time the next scene comes up, the she here refers to the cat, so I will use the same color bounding boxes and share the parameters between these two boxes. But here, the snack is a new entity, so I will start a new color, and that will have its own shared parameters. And the reason for sharing the parameters across the box with the same color is that then they will visually look similar. This was a big problem, right, before this paper came out, is that when you do long video generation, the objects would keep changing. I will be wearing a blue shirt, the next scene it will be a red shirt, my face will look different, the cat will keep changing, the dog's breed will keep changing. So this was right, the focus on the first sort of consistency in long video generation and very fine-grained layout, as I will show. So once all this planning is generated, the second stage is video generator. It takes all these layouts and consistency groupings that I created in stage 1, and then we take a single scene video generation model, and we insert these spatial temporal blocks, which have these guided 2D attention modules, which allow you to have very fine-grained layout control that I just created in the first stage. And the best part is only these guided 2D attention modules are trained. Everything else can be kept frozen. And also you share parameters right across the boxes of the same color. So what all this means together is that we were able to fit this in just 4 A100s or 8 A6000s, right, which is like one academic server. And then obviously a lot of company, right, people extended this with hundreds of GPUs later, which is good. Like they showed it on how to make it look even more visually beautiful, right, and bigger images. Our goal was obviously to fix the problem of consistency and fine-grained layout, right, for the first time in video generation. So I'll show you some examples now, right? So we showed that this model has some basic understanding of physics, like a stone thrown into the sky, so gravity. This is a GIF on loop. It's not like the stone is not going back and forth. And I always clarify that. And then GIF versus GIF is also some confusion that's not clear yet. What's the right pronunciation? I think the guy who invented it wanted it to be pronounced GIF, even though everyone else calls it GIF. But I like GIF. And then perspective, right? It has some knowledge about if a car is approaching from a distance, then you need to zoom in. Again, it's on a loop. It has basic understanding of camera angle and camera movement, right? If it's a bottle on a table, then the camera should move, not the bottle. This is all generated by our model. If it's a plane kind of thing, then the object can move as well as the camera can move. Then for long story generation, it can do multi-scene to multi-sentence to multi-scene. So I'll start this again, right? A mouse is holding a book. You can see the mouse is holding a book and then pulling petals off a flower and then holding the flower by his right paw. You will see this is the right paw here. And the mouse looks, right, consistently the same everywhere. So this was a very big deal, like in Japan and a lot of places, right? This paper became viral on Twitter, like, oh, this will end Hollywood and all that. Because this was like a very, very early paper on like long video generation. So because before this, it was like, there was no work showing how to be able to maintain visual consistency of objects as well as such fine-grained layout of right paw. Right, you're holding the petal in your right paw, which has, obviously there's no YouTube video of mice reading books and holding petals in their right paw. And then you can also do single scene video generation, which is, I can just say something very high level, and it can still generate the whole story and then scene by scene video. So, and then yeah, obviously the best thing in my opinion that all this allows, like I said, is human in the loop control, which means that you can actually, if you generate the initial video and you don't like something, then you can actually go inside the video. I can make the horse box smaller. I can change the background box to grassland or a night street, right? So this is a simple example, but you can do many more complex things without, again, having to just keep trying to change the prompt, which is even harder for videos. So either the human can go in the loop, or this last paper that I'll talk about, which is called video repair, is that if you don't want to have human in the loop, you can also automate this process. If you don't like something, or if something was wrong in the initial generated video, because you have a planning stage, the planning makes the verification of the errors easier. Because if you generate the full video pixel level, it's very hard to actually automatically learn the errors in that generated video. But if you actually go through a planning stage, like I just said, now the verification of the errors can be done on the planner. You can actually figure out the errors much more easily on the plan, and then just fix the plan automatically, right? Not just with humans, and regenerate the video. So that's what we did by closing the whole loop in video repair, where we are able to take the initial video, then use one of our evaluation methods that I did not cover today. We've also done a lot of work on how to better evaluate image generation and video generation. But basically think of it as creating the right set of questions. So if it says one bear and two people making pizza, you evaluate it by creating these questions automatically. Is there one bear? Is there two people? Are these people making pizza? And then you get answers for these just by using a state-of-the-art visual question answering model. And then you know that, okay, this one was yes, and these two questions returned no, which means that I found one bear and one person. And you also ask the model to figure out where is this one bear and one person. You do segmentation to get the region masks. And then you know that, okay, these white parts I need to preserve. I think the battery is running out. So these white parts you need to preserve, and then all the rest of it you can refine. And then you go back to the model and say, here is the parts that you need to preserve, and this is the initial noise function and the initial prompt, and here is the rest of the thing you can refine, and here is the refinement prompt. So it also generates a new prompt, which is basically telling you what else was missing. So you started with one bear and two people making pizza. One person and one bear was automatically already correct. So then all you need to generate is one more person making pizza. So it automatically generates this new prompt. It also tells you what part to not touch, what you can refine. So then it will generate this final refinement video where it, as you can see, it maintains what was correct, and then it inserted one more person. So that's the holy grail, right? Where if I had just done all of this through prompting, I would keep trying to change the prompt. Maybe I would have added this missing person, but something else would become wrong. That was already correct. So this is sort of the right ideal way to already learn automatically what parts were correct and tell the model not to touch it, and then give it a resampled noise function and the rest of the prompt, and only generate that. So this is called video repair, that closes the loop. And then we showed the same power of planning for something more complex like physics-based videos. That's another problem I'm sure you've heard of if you work on video generation, that most of these models are really bad. All of these models are really bad at maintaining physics laws, right? Things like Newtonian laws, penetration laws, deformation laws, fluid laws. So we showed that the power of planning allows you to verify and find trajectories or plans that respect physics laws much better, which is almost impossible to do directly at the video level because it's too many pixels, right? Too many movements. So I'll not go into the details of this paper, but we just put it on archive last month, which is basically the idea that you have an initial frame and an instruction like the robotic arm places the carrot into a metal bowl. So then what you do is this multimodal LLM generates this bounding box plan for us. You convert this to a video sketch, which is basically a composite of images. So it's a very simple way to represent a video. And then whichever one follows the laws of physics better according to a verifier, you use, so you can sample thousands of trajectories in a very efficient way at this point, and then choose the one that respects physics laws better, and then only use that one to generate the final video. As opposed to generating hundreds of videos and then choosing the one that respects physics better, you can do it at the plan level, which is, we showed in the paper, much more efficient and actually better results. Because if you do it directly at the video level, first of all, it's very expensive and slow to generate hundreds of these, but it's very fast to generate hundreds of these. And second of all, it also is not just more efficient, but better results, because you will also make errors when you're trying to directly check physics on the final video. So here's a lot of examples. So this is the same task. Robotic arm places the carrot in the metal bowl. And we have metrics like instruction following accuracy, Newton, deformation, fluid, penetration, and gravity physics laws, and common sense. So this is an existing benchmark that we evaluated on, which comes with all these metrics and examples. And you can see these are all the state-of-the-art open source video generation models. Hunayuan, OpenSora, WAN, CogVideoX, Cosmos. All of these have weird errors like either they are not picking up or putting down, they are imagining things out of thin air, right? Random things will get generated or vanish from the video, or they will violate rigid body dynamics, right? The hand starts melting, whereas ours, right, is much better. And the paper has a lot of metrics and quantitative evaluations. And a lot of other complex examples here. Man in red short jumps forward on the beach. Snow melts and slides down the mountain. And then 2 football players tackle an opponent near the end zone. Robotic arm picks up the purple tool from the toolbox. So we show that a lot of errors, physics errors in WAN, Cosmos, and CogVideoX. But here is our sketch verify, the first column. Okay, so I'll end here. I'll with 2 examples for real-world applications. So like I said, in the first part of the talk, right, I told you about how to do more trustworthy agents for education in the classroom, as well as generating games specific to student weaknesses. Now for the second part of the talk, we have another application in our institute which was accepted recently at ICMI, where we created this tool, almost like a software, for teachers to basically take a very long recording of the classroom, like hundreds of hours, and use visual programming to automatically figure out which parts of the classroom were less engaging, like more boring to the students. They're not paying attention. They are not collaborating well with each other, right? They're just basically zoned out. So that the teacher, right, should ideally use some of this information. And this is all, I mean, we have, like these are done in classrooms where the teachers and the students and the parents, right, all want to be recorded and use this for research purposes. And it's not meant to isolate any single student. We hide all the student faces and identities. It's more to improve the instruction in the classroom on what parts of the classroom could be taught better, to put more focus on the right instruction quality. and how to find, to present or teach the same thing, but with better learning outcomes. And more collaborative engagement is a term from the education community. So what you can do is you can ask very complex, randomly hard questions about different collaborative, concepts like when the teacher walks over to a group of students and asks a question about scientific concepts, are more students looking at her or the laptops? There are also questions about whether students are working together or are they only working on their own. So what it can do is it will take this question and again convert it to a program. It will localize the part of the long video where the question was about scientific concepts from the speech, right, from the speech part of the input. Then inside that clip, let's say it's like the 1.5 minutes to 2.5 minutes. Inside that clip, it will go and find the sub-clip where the teacher walks over to the group of the students. That will be maybe like 1.75 to 1.95 seconds, minutes. Then inside that sub-clip, it will get the gaze patterns, which are different arrows, right, of gaze. So this is all shown here: depth map, object detection outputs, gaze outputs, and then it will use all of this information to finally come up with the answer. So the program gets generated, all these expert modules get activated, and then all this intermediate output is used to generate the final answer. Based on the information provided, it appears that there are more students looking at their laptops, right? So they're not really engaged. And the second example is this whole idea of mixture of agents, where basically what we want to do, right, this is a big part of the future, by the way, right? Like, you will have a library of different experts or agents, right? One will be good at videos, one will be good at speech, audio, music, 3D scenes, medical image analysis, CT scans, OCR, right? Charts, tables, equations, geometric experts. So this is what we did in the MEXA paper, where we basically collected a huge amount of state-of-the-art multimodal experts. And then whenever a new question comes in, most of the pressure is on the router as well as the aggregator. The router's job is to figure out the skills needed in the question as well as the skills of each expert and do a better matching so that it can find that, okay, for this question I need the video expert, the OCR expert, and the equation expert. And then the aggregator takes the outputs of each of these experts, and its job is to how to combine the information from the different experts. Sometimes it will be an easy combination, multi-hop question answering, but sometimes they will have disagreement. They will have conflicting information. So it has to learn how to avoid or resolve disagreements, which agent to give more importance to. So we have some papers in addition to this paper called Symbolic MOE, where we teach and also DART, D-A-R-T, where we teach the aggregator to handle disagreements by making these agents debate and talk to each other and come to a conclusion. So we have also been applying this to one of our new NIH medical projects, which is about early disease prediction. So there is a very big autoimmune disease, right, called lupus, and that's a very multi-organ, multimodal diagnosis, where you need to have information from kidneys, MRI scans, CT scans, doctor's notes, medical history, everything. So we have been using this multi-agent expert with CT scan experts, doctor's notes experts, and they also have to resolve disagreement. So this is, I cannot show too much information from there, but this is one example of like different agents trying to check whether the patient has lupus, and they're actually generating this whole reasoning about pericardial effusion, right, multiple areas of soft tissue edema, inflammation. Then another agent is talking about maybe not possible, it's not, and then the other one might say, I do suspect, and it's giving its reasoning. And then all of this gets combined by the final aggregator, MedGemma, which tries to give a full summary to the doctor, and then its final judgment that even though imaging itself cannot definitively diagnose lupus, certain findings in the CT scan is raising suspicion. So in fact, we have a lot of very world famous experts like doctors in our team, because UNC and Duke are very top medical schools. And we were showing them some of these methods get 5 to 6% improvement, and we thought it's maybe not enough. We wanted bigger improvement, but they were very surprised and impressed that, like, they are surprised even with 1% improvement. And more importantly, they are pleasantly surprised by some of the kind of information that these models are providing. Because even, like I said, even if the doctor cannot trust, and they will not replace themselves with this final judgment, but it gives them a lot of information to look at, which they might have missed. Because they're very busy, right? It's hard to scale human doctors. So this is another use case, just like education, this is a use case where different medical agent, AI agent experts are giving their opinions and very detailed reasons of why. And then they're also actually debating and trying to disagree and agree with each other to come to a consensus. So that's one of the best ways to actually give all the perfect information to the doctor, and then the doctor can decide, right, what to do with it. As opposed to either only relying on the doctor or only relying on one agent, which is very biased. Yeah, so I'll end here. Some big conclusions and challenges going forward that I usually end with. So one is the usual trade-off, right, between monolithic pre-training versus having some modular structure, right? So hopefully I gave you enough evidence of the advantages of modularity, right? More faithfulness, efficiency, but the best part is it allows much better verification and execution and refinement. Then if you want to work on multi-agent communication, right, I touched upon persuasion and confidence calibration, but we are also working on bigger, longer-term factors like the reputation of an agent. What reputation will it build over time, right? Just like humans, we build a reputation of being a good team player versus not. Mixed cooperation scenarios like negotiation, right? I also talked about ambiguity loopholes, safety of AI agents, right? Things like agents have started becoming very deceptive, loophole exploiting, keeping secrets. So these are big topics. True self-refinement, right, is the holy grail. In my opinion, one good way to do it is through automatically discovering structure inside the task, and then, right, using that to do better planning, verification, and data generation. I think I'll end here. So, I mean, you can look at the rest of these. I'll send the slides. And then, yeah, thanks to all the students for their hard work. And then we are always hiring PhD students and postdocs. But like I said at CORDS, some of my recent students are faculty and postdocs are faculty at Johns Hopkins, UT Austin, and Singapore. So make sure to apply to them before you apply to them. Thanks.
Thanks for a great talk.
Thanks.
I wanted to know, sometime back in your physics example, you mentioned it's expensive to analyze the videos for correctness, so you analyze the plans instead. So are the plans output in some kind of an intermediate format?
Yeah, so it's called intermediate video sketch, which is basically the third box here. So it takes the plan, but then it combines it with the background image and stitches together the images generated based on the plan. So it's like some sort of cheap efficient way to stitch together images with a static background. It's called a video composite video sketch, and it's warped composite video sketch is the technical term.
It's still visual.
Yeah, it's exactly
it's
like
exactly
this, but it makes it makes the verifier's job much easier to verify physics and other things on this as opposed to a fully generated video.
I see, okay.
Yeah.
I was thinking maybe it's a textual output of what is supposed to happen.
What output?
A textual
No,
plan
no.
output, no.
Yeah, I mean, you could do that. It will probably add a little bit more information, but most physics-based things are not very good at being verified through text.
Yeah, true.
Text is good at its own things, and then some things have to be more visual.
Yeah,
Yeah.
I guess you would need a lot of...
I mean, if you have a really good model that can generate a very, very detailed movement-based caption, but then that's its own research problem.
a lot of description.
If you could have already done that, then in some sense you're also solving physics in a different way. Because then if we already have a model that can generate a very detailed physics motion-based caption, then in some sense you have a model that understands physics. So it's sort of a chicken and egg problem. But these kinds of problems so far work much better directly attacking at the visual level.
Okay,
Thanks.
thanks.
Any other question?
Yeah.
Thank you, sir. Good afternoon. It is an excellent presentation for us, a lot of inputs. What I wanted to know, I'm not from the research or the education background, I'm from the industry.
Yeah.
So, a lot of insights have been given into the presentation about how the output of a multimodal AI agents could be improved in between stages like an MLLM output and plan on all those things. But is there any work which is being happening into the research world about and how the input, like in the prompt, mostly as the end users, what we see is we have to do a multiple time of prompting, which is a textual prompting.
Yeah, there's a lot of work on multimodal prompts.
So is there any work happening onto the improving the input from the end user
Yeah,
side?
there's a
Because
lot.
most of the time we are using only textual information.
No, there's
to
a
the
lot of
input.
work. So actually, I skipped a slide. We have a paper called Control Adapter, which was a top 2% oral at iClear this year, where you can give text input, sketches, you can even
Oh,
draw something,
okay.
you can give depth maps, you can give segmentation maps, you can give various different kinds of inputs. And in fact, we showed how we can efficiently combine multiple inputs to respect each other through a new mixture of experts approach.
Yeah.
So it's called CTRL control adapter. You can check
Okay.
it.
And is that also considered the structured kind of an inputs, like an
Yeah.
specific kind of an information needs to be
Yeah.
given?
So that puts
given
more
at the
pressure
beginning?
on the input.
Yeah.
Right. So that's another paradigm where, I mean, if the user is available and happy to give you more structured input, that actually makes the task easier once you figure out how to combine all that information. This is more about when the user doesn't have time and can still only say something in words, maybe 5 words. Then the pressure is more on the model, inside the model, how to then convert that prompt to all the visual planning.
Okay.
So both can work together. But what you're talking about is actually easier because like you're already getting so much information in the input. But then the challenge there is more on how to use that input together so that they don't conflict each other. So you can check control adapter paper.
Thank you.
Thanks.
Any more questions? Hi. So I'm also from industry. What we were trying to, what was most interesting is the improvement in the coding side of it, the refactoring side of it. What we were trying to do is improving the productivity of our developers and the overall process. We tried GitLab Duo, MCP and many other things. I see refactoring was performing excellent during the single class or a couple of files, but what was the major problem was the biggest, the larger context of the overall deployment or maybe the business logic, right? Is there something that is coming up in that area where the context can be understood by the agents or LLM and then it kind of works out?
Yeah, I mean, there's a lot of connections, right? There's context. I mean, there's models that are doing better at combining external RAG, right, context versus parametric knowledge inside the model. So we have another line of work on how to balance internal parametric knowledge of the model versus external retrieval knowledge.
Okay.
So that's something where you can feed in a lot of external context, right, through RAG. But then you also need to make sure that it's able to get combined properly with the internal parametric knowledge of the model.
Right.
And then another big area is long reasoning, right? Deep reasoning, I mean, whatever you want to call it, where you're generating very, very long reports. Both we and other groups have a line of research on how to automatically generate very, very long reasoning, but then also learn how to refine the wrong parts of that reasoning. Through different kinds of reward models, like process reward models, which is basically a word for stepwise rewards.
Okay.
Yeah.
Okay. Thanks.
So just maybe a continuation of the prior question. The aggregator, I was just trying to understand in your example, is the aggregator sort of, bringing the earlier decision makers also into the picture in order to sort of collaborate and come up with a better answer if it figures out somehow?
So who are the earlier decision makers?
Yeah, I mean, I forget the names in the example.
You mean the experts that were selected?
Yes.
Yeah. So it's, I mean, the one I gave, this paper is just one example, but some of the follow-up works we have on archive called DART, as well as symbolic MOE. That's where all this is happening. First of all, we are showing that you cannot trust every expert on the description that it comes with. Right? A lot of the big tech agents will come with just some description, good at math, right, blah, blah, blah. But we showed that actually you cannot just trust that blindly it will be good at everything in math. So we actually first take every expert in symbolic MOE and learn a fine-grained profile of its skills. That it's good at maybe linear algebra, but not good at calculus, right? Those kinds of things. And then the matching and the selection of the experts becomes much better, as you can imagine, because we have very fine-grained information about what every expert is good and bad at. And then on the aggregation side, it's more like, I skipped one of those slides from the CORDS talk. I skipped it here, but we have work called Reconcile and these kinds of papers where we showed how to have a very useful debate between different agents or experts, such that they look at each other's reasoning and then decide whether they should change their own reasoning and answer. But in a very careful way, because you don't want them to again get influenced by wrong reasoning, just because one model is being overconfident, right, and saying, no, my reasoning is the best because of blah, blah, blah. You don't want the other agents to change their reasoning. So what we showed is the right way to do it is, first of all, take into account also the confidence of each agent. And second of all, we teach each agent in this collaboration to only try to convince other agents when you have a better probability estimation of improving their answer. And we did this through a few examples of what we called corrective convincing, where we give it 5 or 6 in-context learning examples of when did someone's reasoning change your answer from incorrect to correct. So then models learn that, okay, in the future, I should only try to convince other agents when I'm more likely to change their answer from incorrect to correct as opposed to. So we showed a lot of that paper has become one of the more fundamental, like multi-agent collaboration papers called Reconcile. So we brought in a lot of that also in the aggregator here. Okay. And then DART, the DART paper recently, we should hopefully get accepted at ESCL or ACL. So it's in the ARR process. That one shows a lot of details about how to handle disagreements between agents.
Okay. Yeah. Okay. Thanks. Yeah.
Hello, sir. It was a nice talk. Actually, I'm also coming from industry. So we are solving a problem of identifying phishing links.
Identifying what?
Phishing links.
Phishing links, yeah.
Yeah, so actually after AI, the game has been changed for the phishing and all those areas. Every time you see anyone, any person can generate a website for looking alike to ICICI, HDFC Bank and whatever. So that game has been changed and we have not been picked up in that area. We have been working on training a model and able to put a scale of 3000 links per second, and we have also managed some hardware into it. So
what's the main solution to identifying fake web pages? Because that's a very big debate, right?
Yes.
I mean, at some point it will be impossible to differentiate. So I think the solutions will be more in sort of cryptography and security community, right? You'll have to exchange keys. You'll have to have watermarking keys. Even watermarks can be faked.
So we have categorized.
I want to first hear from you, like what's the main, what do you think is the main solution for identifying automatically generated web pages?
So automatically generated web pages have some categorization. So one categorization would be like, it would have a similar domain name kind of thing. So you check with the brands. Second, things come once we see any of the logos. So we open the web page in our Tor created network because too much attack happens on our server when we check this kind of thing, because it is hosted on dark web and they get the IP and they attack us. So we do that.
So certain kinds of these subtle features, but what I'm trying to say is that in the near future, all those will also be hard to define, because the sort of adversaries will try to imitate all that.
Yes.
Right?
Yes.
Right now they're a little bit out of distribution.
Yeah.
So it's a chicken and it's not a chicken, it's a cat and mouse kind of game, right?
Yes,
Just like the cryptography community, I mean, cybersecurity community, there's like the attackers will keep getting better, the defenders will keep getting better.
Yeah.
But end of the day, there'll have to be external solutions like watermarking, but with keys, right, that are exchanged, and private keys. Because in image and video generation community, what the things you are saying, or even text generation, right, these are already fooled.
Yeah.
Because people, I mean, the models can actually now even generate, insert human-looking errors into the text that they're generating, so that it looks like it was written by a human, right?
Yes.
Because what the pro VC was saying is that like it looks very good English, right? And then he knows that it's not written by the student.
Yeah.
But now actually the student can in fact insert errors, right, and then make it look like they wrote it. So this is an continuous sort of back and forth process, right? Because the same thing here, I can like the agent could match the domain and like match the distribution of attacks such that it looks like it.
So we have nearly 10 to 12 categories, and the model actually checks for each of the category, and according to the weight it actually gives a scoring to every site.
Okay.
So we have 4 stages of any phishing attack. So anything comes up, first we get the feeds from the domain servers from where the links are getting actually routed to the actual website page. So I mean, we have 24-hour running server which actually uses the AI model, and we still have some problem in that. There are false positives, and then we have so much of we want to do a multimodal approach.
Exactly.
So once we came to know about your
yeah, I'm happy to chat. But that's what I meant. I think it has to be a multi-pronged, multimodal approach where it cannot just be. First of all, your agent itself needs to be first behaving like the attacker to understand the attacker better, right?
Yeah.
Only then it will be able to detect what was generated by the attacker. So it's kind of like a GAN and inverse GAN, right, kind of situation where generative adversarial networks. But like I said, there has to be external factors through other modalities, through other sort of, in your case, network stream, like the network packet properties. So it will have to be a lot of other modalities.
Yes, it has.
Yeah.
So actually it has too much of categories. First we started with 4 or 5 categories. Then we started making it according to the behavior, because the game has been changed on that side. It is like you just...
So behavior is the key, right? If you see the last slide I said, that's why I was giving this slide on long-term factors, right? The reputation. So you see the word reputation there, right? So if you start analyzing long-term behavior of a certain website, these kinds of things are the way to go, because short-term will not be enough.
Because what happens, you get one link, that is, they will run a campaign, they will fish people.
Exactly.
Then that link will be gone, new link will come and point to the same
Yeah, so
IP.
it's not just like multimodal, it's more like they'll have to be like, that's why I called it a long-term reputation, long-term behaviors. I think, you see like safe AI agents based on addressing behaviors such as deception, secrecy, right, reputation, long-term reputation. So behaviors is the keyword, like you said.
Yes, it is.
Cool.
Thank you.
Thanks.
Yeah.
Okay, so I can take more questions then offline.
Any more
I
questions?
can stick around.
Other we'll take offline.
Maybe one. Yeah, I think one from this side is good. More student questions. This side is sitting a bit quiet.
Sir, I'm a first year student, so as Pro Vice Chancellor sir, and you repeated the topic that that English was good and all. So even our assignments are checked through, the online assignments are checked through plagiarism detection softwares and all. So initially we were scared, as we were new, that if we copy content from AI, we will be caught. But by the end of the semester, we found out that how to dodge it if we insert few grammatical mistakes and comma and all, if we dodge with it. Those
but you are moving on from that, right? It's like, I thought you will say something after that saying, but then we realized that we're not learning anything. So we stopped doing it.
No, like from students' point of view, we learn how to dodge those softwares.
Right.
But then what's the use of that software if they can be dodged so easily? So is there any solution to...
I mean, probably the software is not good enough because, so the more advanced software was used for iClear reviewing, right? So that one of the top machine learning conferences, ICLR, this time they actually flagged reviews based on a very new state-of-the-art system on how likely is this review generated by AI. And they actually made all this public so that authors, like the reviewers, can actually be embarrassed. And then ideally they will even blacklist reviewers, right, who use too much AI or reject their own papers that they submitted. Same thing for AI written papers. So, these are simple cases, but they are much more advanced because you can actually check, you can still find some certain subtle distribution differences. If you look at some very low-level distributions between your text and it will still be able to figure out that the errors were added post hoc as opposed to the natural initial distribution of errors.
most of the times it just detects
But more, this is a bigger debate, obviously, right? How to actually learn more truly in the classroom. Because otherwise students, like she said, will keep trying to find ways to break the system because it becomes almost like a challenge, right? A fun challenge or something. So we have this debate a lot in UNC and in the US too. And I mean, some faculty are just going back to pen and paper, right? That nothing allowed in the classroom, just pen and paper, and like, let's try to learn something. And then the second approach is allow everything, but then the pressure should be more on the faculty to create more out-of-domain questions, right? Things that are not just, I mean, so things that you should already be able to check that the model will not be able to answer, at least for now, right? Let's see what happens in the future. But creating questions that are not easy by the model, or maybe another thing I proposed, which was at least interesting to the audience that I was giving it to, is where maybe instead of asking students to answer questions, maybe give them the answers from the model already, because they'll do that anyway, and then ask them to become the grader. Right? So instead of being the student, make them the grader and give them AI-generated answers from the model, and then ask them to grade what part of these answers are correct or incorrect. So first of all, then you are actually making them learn better, because they have to be a stepwise reward model. They have to actually annotate every step of the answer. And this way also, instead of them generating the AI answer, you're already giving it to them. Now grade this. So anyway, I'm giving them some ideas to help you learn better. Yeah.
Yeah, one of the IITs opened up with respect to this aspect. Like what they said, like if you are submitting your assignment, try to submit your prompt also. We would be giving marks to the prompt, not the answers.
Yeah, I've heard of that too. But I still feel like that, I mean, that only will go so far. Like, we are not making them better prompt engineers, right? That's already a job that is like completely dead, people are saying. So it's better than not doing that. Definitely. But I think making them grade AI generated answers, that's the only solution I could think of.
Yeah.
Because then you actually have to become, like being a grader is, like a teaching assistant is a harder job than being a student, right? So if they're getting so much easiness because of the AI answers, then their job should also be elevated to do something more interesting and harder. And then that checks your learning of the class much better if you can actually grade someone else's answer, right? Yeah. So like an advanced student will be able to be a teaching assistant, right? Advanced undergrads, right, in good universities everywhere, become teaching assistants for freshman classes. So same thing. The models right now, AI agents, are kind of like high school or freshman level. So we should make our students grade their answers.
So what she was referring to, I asked them to write a dialogue between two pioneers.
Yeah.
So I could really identify the kind of dialogue everyone added was AI generated. Okay. Thank you very much. Thank you very much.
Thanks. Thanks.
We are really thankful for your insightful talk. So as we come to the end of this session, I would like to express our sincere gratitude to everyone who made this program meaningful and successful. We extend our heartfelt thanks to Dr. Mohit Bansal for his inspiring talk. His session has given us valuable knowledge and new perspective that will surely benefit all of us. We are also grateful for Honorable Pro Vice Chancellor for his presence and Honorable Vice Chancellor for his encouragement and continuous support. We sincerely thank the Head of Department of Computer Science for helping us organize this event in collaboration. Our special thanks to IT Cell for providing excellent technical support and managing online streaming for the session. I would also like to take this opportunity to thank Department of Geology for support and managing and for their cooperation. We also thank the participants who attended the program in person and who joined us through the live session. Once again, thank you for your support and cooperation. Before we conclude, I would like to tell everyone that there are snacks and tea arranged. I request you all to kindly join us and enjoy the refreshments. Thank you.
So from Computer Science Department, Savitribai Phule University and authorities of university, We want to thank Professor Bansal for the song. So I request all participants to be here. Yeah, like we will have a group photo. Please join us. Yeah, they will take it.
So just one more thing. I think this is something that I missed. I think this event and his talk